Thank you, Chris. Good Monday morning to you all. I'm really delighted to be here in Brisbane again. It's my favorite stop on the YOW tour. When talking about grinding the monolith, I have to start by actually praising monoliths for a little bit. It's not mandatory. Like talking about Conway's law is legally required. Anytime you talk about microservices, praising monoliths is not a legal requirement, but I think it's good to pause for a moment and say, what's so bad about them? In fact, even the word monolith is kind of a retronym. Before 2010-ish, we didn't really talk about monoliths, we just had programs, and we put our programs on servers. We use this word to contrast with the new shiny way of doing things in microservices. And we sort of just use monolith to mean that bad old thing that we don't want to deal with anymore. But actually, I think there's a lot to like about monoliths. They're certainly easier to deploy. I mean, you kind of have one artifact and you put it out on your servers and it's there. When you need to implement features, the question is, where do we put the feature? Well, it goes in the monolith. Everything goes in the monolith. It's one box. So there's a lot to appreciate. When you're debugging, where's the bug? The bug is in the monolith. You might need to narrow it down a little bit more than that. But when we move away from it, we start to adopt a lot of operational complexity. We can't deploy things as easily. We have to start thinking about having part of our system there and part of our system not there. Our systems live in this state of continuous partial failure when we're moving away from monoliths to smaller pieces. And so clearly we must be gaining something if we're willing to make that trade. And what we're trying to gain is independence of development, independent scalability, and building things in smaller, simpler pieces. But I've kind of heard that story before. We had these things called Java beans that were supposed to be independent components. You could just buy off the shelf. There would be a marketplace for Java beans. You'd go and buy a pound of software. We've also had enterprise Java beans, which are basically the same as Java beans, but they cost 1,000 times as much and work less well. We've had dependency injection that says you can build your classes independently and then just weave them together with XML. And then XML was too separate, so we said we'll do annotations and weave things together with annotations. Over the years, we've also had COM and DCOM and Corba and many other technologies that all promised to let us build our systems out of smaller, simpler pieces, loosely coupled. So why now are we talking about microservices and not DCOM objects? Well, part of it has to do with some recurring idea that we can just snap together our software out of components. Like you might build things from Lego bricks. We've had something at one time called the software IC idea, the integrated circuit. Like you could get a piece of software with a standard interface, just like you can get a microchip with a standard interface. An Australian researcher named James Noble has looked into this Lego hypothesis, and I had the good fortune to see a talk of his. Spoiler alert, it was called the death of the Lego hypothesis. So he's not very optimistic about it. And the observation that he made is that Lego has a very simple interface. You've got dots on one side, you've got holes on the other side, dots go into holes, they plug together like that. But crucially, a brick of Lego only interacts with its nearest neighbors in three-dimensional space. If we start looking at interactions in our software, we can analyze the coupling among different portions of our software, and there's a remarkable curve that emerges in almost every project of every language in every technology, and it looks something like this. This is a power law, and it occurs pretty much anytime you have a self-reinforcing system. So a piece of your software, called a class, a namespace, a function, that is used in many places will tend to be used in more places. And so it has a sort of rich get richer kind of dynamic that reinforces the number of connections. One of the characteristics of a power law is that the average is not a very good description of the extremes. So here we have the average number of connections among components in software, and it's kind of a moderate number. The median number of connections is much higher than the average, and the mode is much, much higher. Well, when this happens, you can start to say, if I graph out these connections, I'll find a class in my system that has hundreds or thousands of collaborators. What kind of a space would we have to have for a class to have hundreds or thousands of collaborators adjacent to it? Now, I'm pretty good at visualizing things, but I still kind of cap out at maybe 5 or 6 dimensional visualizations. We'd have to use 1,000-dimensional spaces to represent this kind of connectivity. What would a Lego brick look like in 1,000-dimensional space? I don't think you'd be able to make Lego work with just dots and holes if they had to have 1,000 nearest neighbors. In fact, the Lego model of 3-dimensional connections is not a very good model for software. A better model for the connections in software is more like mycelium. These are the threads of a fungus that knit together underneath the surface. Before you ever see a mushroom, these threads are growing throughout a space and connecting, and they make these kind of far distant connections in a similar way to our software. So you can stimulate one of these threads way over in one part of the mycelium, and chemical signals are passed to what appear to be far distant locations. Our software sometimes kind of feels like this. We make a change in one place and we get an effect in some far distant location. That's because the connectivity doesn't follow a simple model like 3-dimensional space. It gets a lot more fungal, fractal. We draw diagrams like layers. We've probably all had a picture like this and thought that we're building software this way. If you're in a large system, hopefully you also introduce some additional separation, like you want to have some components with vertical separation in different functional areas of what you're doing. But a project comes along with a tight deadline, and you make a deliberate decision that says, I'll just make this one horizontal connection across the boundaries. Just one call. I know what I'm doing, not like those other schlubs on my team. I'm allowed to make this decision. And pretty shortly, some architectural erosion sets in, and you start to get the mycelium growing horizontally across your domain layer. And at some point, even the lines become a little hard to see, and you start making these vertical calls as well, and you get something that people start to call spaghetti, or a big ball of mud, or the hairball. I was working with a client one time, by the way, that described their cleanup project as combing out the hairball, which is a fantastic image right before lunch. Well, when we have this, we've got that mycelium, and effects are felt in locations that appear to be far distant from their causes. Oh, but the picture's even worse than this, because in addition to the layers and the architectural erosion among the layers, we also have these cross-cutting concerns that get mingled in to every layer. Things like operational issues, authorization, authentication, monitoring, logging. They intrude into our software. I want to take a moment to talk about layers because we sometimes treat layers like a natural fact about how you build software, but they're not. They're a choice. They're a pattern, if you will. In fact, in Pattern-Oriented Software Architecture, Volume 1, the authors identified layers as an architectural pattern. And it's interesting to look at how they described the situation where you would apply layers. So we have this context that says it's a large system that requires decomposition. Okay, I can live with that. Pretty much all of our systems have that context. A mix of high-level and low-level concerns. Yeah, all right, we're there, got that. Several operations are at the same level of abstraction. Well, yeah, also true. But when we get into the forces, things start to look maybe a little questionable. Let's look at this one that says interfaces should be stable, may be standardized. Have you ever standardized the interface to your domain layer? Does that even make sense? What about standardizing the interface to your persistence layer? Parts should be interchangeable. So I'm going to swap out my persistence layer with the persistence layer from another project. No, I don't think that's going to work. Other systems may reuse lower layers. We actually think that's explicitly a bad idea now. So some of the forces here that motivate layers in this situation don't even apply. So we should reconsider whether the layers pattern makes sense for each of our projects. I'll say that the layers pattern here was really meant to mediate from high-level concerns to low-level concerns in things like protocol stacks, not crossing functional concerns like UI, domain, and persistence. So we need to think about that a little bit more. For me, when we're moving to microservices, the key issue is really around safety. And when I talk about safety, I'm not talking about, autonomous vehicles crashing into people. I'm talking about safety for different teams to operate independently. So if one team can write a line of code that exhausts a thread pool and causes the software to stop responding to all requests, you do not have safety. If one team can write some code that exhausts memory or fragments memory or uses up all of a critical resource, you do not have safety because all features are deployed together in one process, in one runtime, on one machine. They're all damaged together or they're all destroyed together. So it's really that aspect of safety that most interests me when we're trying to move to a microservices style environment. And in particular, anytime we don't have that property of safety, you'll have some kind of an outage, some kind of a failure, and you will suddenly spontaneously grow a new review process before you can deploy software. And so you get release management growing in power, and you set up this feedback cycle that I call the fear cycle, where an organization that begins to fear its technology makes changes more hesitantly, and pretty soon actually should fear their technology because it will get out of control and you'll lose your leverage, you'll lose your ability to make changes in it. Well, when we have monoliths, we have safety failures of several kinds. Bad code can have an unlimited span of effect. So you may have 10 million lines of code, and a one-line bug in handling SQL exceptions may cause you to leak all of your database connections and hang all the features of 10 million lines of code. So there are no boundaries. We have a lot of common mode issues. A common mode is when you have two different components that have a shared reliance on some third component. For instance, something like a persistence layer. One of my clients really liked the JPA, Java Persistence Architecture spec. They liked it so much that they built their own implementation of the 0.9 beta version of the spec. And then they didn't update it when version 1 came out. And they didn't update it when version 2 came out. So 10 years later, their entire monolith was using their derivation of a draft version of the spec. No one was particularly happy with this, but no one was willing to make changes to it either, because every feature in every part of the domain all funneled back through that JPA code. And so if you were working on something like the order management portion of this system, and you made changes to JPA, you would do it with great fear, because you might be breaking people that you've never even met. We also have this issue of semantic coupling. Semantic coupling is usually invisible, and it happens when you have two completely different implementations that make the same assumptions about patterns of data or patterns of interaction. So I have two classes that don't directly import anything from each other, and yet the way they use some table or entity or external interface has to remain the same. And so again, if you change one of them, you've broken the other without knowing it. This effect, this action at a distance, is what makes people afraid to make changes. It's what makes changes slow, and it's what makes review processes inevitable when the breakage does occur. So we say we're going to break this down. We're going to comb out the hairball. We're going to straighten the spaghetti, whatever metaphor you like. Well, I've been involved in several of these transformation projects now, and I have some bad news. This is a very, very hard road to go down. Of the projects I've worked on, 2/3 of them have not succeeded. And when I say they've not succeeded, I mean that the project has been canceled, the company has gone bankrupt, or it has just outright sold itself to private equity and stopped doing what it was doing before. So a lot of these transformations are not going to work. I'm going to relate to you some strategies that we've tried that I think don't work. I'll relate to you some strategies we've tried that I think do work, and some that have sometimes worked. Now, I'm not going to tell you which is which, so there will be a quiz at the end of the talk. No, of course I'm going to tell you which is which. But in general, the things that derail these projects tend to fall into one of these categories. Impatience is a big one. So you spend 10 or 15 years building up a monolith, and then your executives want it to be completely broken down and rewritten as microservices in a year or 2 years. Well, impatience can also come from the development side too. It's too difficult and it's going to take too long to really analyze all the coupling inside of this, so I'm just going to build something new because I'm much smarter now than they were back then when they built the old thing. And so surely it can't take that long to build the new thing. This bleeds into the unrealistic expectations that somehow we're just better now at everything we do than the people 10 years ago who built the monolith. They just didn't know what they were doing, but we know what we're doing. And a touch of hubris. I think all of these factors lead us into trouble. So let's talk about some strategies. One of the ones that is sort of most obvious, easiest to explain, and most intuitive is the idea that we're going to first introduce some internal interfaces inside our domain so that we can get some separation where things are too tightly coupled now. And then after we have those internal interfaces, we can turn that into a process boundary and make those calls across the process boundary. I call this clean then separate, and it's a very appealing idea. First of all, it is incremental, so it avoids some of the problems of a big bang rebuild. Second, it's working with what we know now. It's also quite easy to explain to the technology team and to the executive team and so on. But I have not seen this succeed. One reason is that it takes too long, and you sort of have to tell people you're going to halt feature development while you're doing this cleaning and separating. So if you halt feature development, you're effectively telling your sales team, hey, I hope you're really good at PowerPoint because I've got nothing new for you in the next 2 years. Depending on your organization, the sales team may have enough power to veto that prospect. On the other hand, if you do not stop ongoing feature development, then you sort of have one team, call them the clean team, that is out there building the new stuff, combing out the hairball, and you have another team that knows their work is throwaway. So they're going to do it in the most expedient way possible. They're going to hack it in however they need to get the features done. So the clean team is probably moving slower because they're doing this hard work of really decoupling things. The feature team is putting them on a treadmill, and the feature team kind of doesn't really care too much about how they get the work done. Now, suppose the feature teams really have very high personal integrity and they want to do good work and they want to build the new features in a decoupled way. But whatever kind of abstractions they're going to create or decoupling they're going to introduce, they know that it's not what the clean team is doing. And so even if they want to do the hard work and do it right, they're not going to be able to. So I have not seen this approach succeed. The next most intuitive approach is to take kind of a domain-oriented view and say, in my domain, I have certain key concepts. I have these nouns that are central to my system. They're probably pretty easy to find because they'll be the biggest classes in the existing monolith. You know, that hairy class with like 200 methods on it, and it's got an interface with the same 200 methods on it. Look for the classes named something impl. These are the ones that people will look at, and they'll try to turn them into services that manage instances of that class. These are entity services. And in fact, there are some textbooks and some frameworks where their demos are basically about creating a layer of entity services and then creating a layer of process services on top of that. I regard this as a failed pattern as well. Again, it's very intuitive and it's a logical kind of thing to approach. But when you have these entity services, they're sort of the target of every invocation. So if you imagine requests coming into your system from outside, trickling through a layer of services, they're all going to end up at these entity services. And because there's a small number of the entity services, most of your request types from most business processes are going to end up at the same entity services. And then you take one of your processes, and it's calling multiple entity services to try and maybe do a get, make some decisions, put, something like that. Now you have transactionality problems. People sometimes ask me, how do I deal with transactions in microservice systems? And usually the answer is, because you need transactions means you're doing entity services, and let's find a way to refactor it so it's around behavior, and each of the services has just the data it needs for that aspect of behavior. You will not have a customer service that knows everything about your customer. Instead, you'll have a constellation of services that each know something about your customer and present an abstraction of behavior about that aspect. This will actually make deployments much easier. You see, when you have entity services, deploying one of the entities is very disruptive because every business process depends on it. You have effectively made a distributed monolith. But if you go to these behavior-oriented, facet-like services, you can deploy one of those and you only lose the features which depend on that facet of that entity. The next failed strategy is also a very common approach for staffing some of these efforts, and it's the idea of having project teams. So I'm going to run something like a transformation project with a team that's there for the duration of that project. Often it's augmented by consultants, but it's essentially just drawing people from a pool and telling them, you now care passionately about this thing that you'd never heard of until yesterday. And then once you're done with it, you're going to stop caring about it and somebody else will take it over. Well, one of the problems with this is that the project team and the management of the project team is measured on hitting a target, not on creating assets or creating long-term value. And so you'll often be motivated to get things done in kind of a short-term fashion without an eye toward the long-term health. I had one of my clients where I had been there at one point and we spun up an initiative to get automated acceptance tests wrapped around this old system so we could split it up. Spent about $3 million on writing tests. 2 years later, the tests were gone. I asked what happened. Well, there had been a project where the project manager authorized the deletion of all of these tests. I said, well, why would you delete the tests as part of a project? They were failing. Wait, wait a minute. There's also another sort of more subtle aspect to why I don't like project teams. If you're doing the hard work of cleaning up and separating a monolith into smaller pieces, and it is very hard work, if you do a good job, you should be able to live with the fruits of your labor and enjoy the benefits of this habitable code base you've created. You shouldn't be pulled off and assigned to the bigger mess next door. But that's usually the reward, right? If you're really good at cleaning up a mess, your reward is a bigger mess. So if you're good at cleaning this up, you should get to live with the results. And if you don't do a good job, you should have to live with the results, because you'll learn. So I would much rather see product teams than project teams. A product team consists of people who can make decisions about the direction of the product. Sometimes we call them the business or the product owner or the stakeholders. It consists of people who can make the changes to the product and people who can evaluate the results of making the changes to the product. So you should be able to follow that full cycle within the team and on your own schedule. Now, you may be on a product team where you decide to do a project. But a project in that case is an initiative within the product team that's executed by the product team, and the people remain constant. So you finish off one project, you tackle another project, and you're using that as a way of measuring or managing your own work. It's not a way of pulling people from a pool, throwing them into a code base, and then throwing them back. The next failure strategy is the idea that we can start with a blank sheet of paper and redesign our world based on our now superior understanding of what that world should be. I think it was Joel Spolsky who wrote an article a long time ago about legacy code and the rewrite fallacy, where he said, you know, we always look at the legacy code and we find these little weird if statements and these loops and these bumps and special cases, and we think, man, that was dumb. But really, it was there for a reason. You know, each of those things was put in there as the response to a bug. And so when you do your clean sheet design, you're sort of guaranteeing that you're going to recreate all of those bugs and rediscover all the special cases that motivated the weird bits and bobs of code. We also approach these with an unrealistic expectation about timelines and completion. So we make the same mistakes in our new system we made in the old one. We also tend to be aggressive about how much we put in. So Fred Brooks coined the term the second system effect. At least I learned it from his book. He may have learned it from someplace else. But the idea is the first system was limited. It was a product of compromises. We didn't get everything we want. So by God, this time we're going to do it right. We're going to add in all the features we didn't get the first time around. We're going to have a clean architecture, and the scope just balloons out of control. So the second system is the one that everybody gets too optimistic about. They pack it full of hubris. It's the third system that works. Sort of like Swamp Castle for any Monty Python fans there. Well, the optimism that we approach this redesign with is not justified by past experience. In his book, Thinking Fast and Slow, Daniel Kahneman talked about a curriculum redesign committee where they were estimating how long it would take to redesign the curriculum for this particular program. It went around the room of academic experts and came up with a conclusion of 6 months. Kahneman asked one of the people, "You just finished a redesign effort for this other curriculum, right? How long did that take?" "Well, it took 2 years." "But you just estimated 6 months." "Well, it took 2 years because we had these delays and there was an interruption and we had a replan halfway through. Some people had sabbaticals and tenure." Kahneman's thinking, well, what makes you think those are not going to happen this time? So he started asking around, and turns out several of the people on this group had been involved in previous curriculum efforts, and the rest had been near one. Their colleagues had taken one on, or they had observed one. And no one had ever done it in less than 2 years, and these were the same people that just had a consensus estimate of 6 months. Be very, very cautious about that. What happened last time is most likely what's going to happen next time. So instead of sort of pulling out a fresh sheet of paper, I advise you to design in the context of what you've got. You already have a working monolith. Use that as your basis. Start from there. You will not arrive at an ideal design. if such a thing can even be said to exist. You'll arrive at a design that shows its history. Someone coming in from outside will look at it and they'll go, well, this is kind of weird. Why is that there? And you'll go, well, there's some historical reasons. Let me tell you about the lore of our system. Come, sit by the fire, friend. I'll tell you the story of our people. It's okay that it reflects the past that it has lived through. Photographers like to take pictures of people whose faces tell a story, deeply graven lines around their cheeks, crow's feet that may go down if they've had a hard life, or up if they've had joy and laughter. Your system can have that kind of character. We often like old buildings better than new ones because they show some vision of the past, some aspect of the journey they've been on. So we can allow our systems to have that same kind of character. All right, well, that's like 4 failure patterns in a row. So I think I need to move on to something that actually works, or partially works. And this one's called the strangler. I learned about this one from Martin Fowler. He wrote it up as a pattern and says you basically intercept traffic, or you intercept the functionality of your existing system, and you start off with just a thin layer that allows you to get some leverage over where the work goes. And you take sort of one piece of work at a time, one transaction, one request type, and you write some new code that handles that outside of the monolith. And the strangler may, in fact, even call into the monolith at various points. So it's not totally independent. The metaphor here, by the way, is not a serial killer throttling the old application, but it's a strangling vine that grows up around a tree. The tree provides structure for the strangling vine, just as the monolith provides structure for the strangling application that gradually takes over piece after piece after piece. Being able to redirect traffic like this allows you to do things like dark launches, or traffic duplication, where you compare results from old and new, and you say, is this really working, this new piece of code I've written? And you're using it in production on real traffic, you're just not sending the results of the new service back out to users. So I will say that this approach can work. I've seen this succeed. It also produces a design that you would not create from a clean sheet of paper. Again, that's okay, we're going to live with that. If you do this carefully enough, then what you're gaining is the ability to make more changes and more rapid changes in the future. So your initial design may look a little odd and ad hoc, but you keep working at it and you keep working at it. You split these things up, you join those things. Use the strangler as a transitional pattern to this new way of working. Another successful strategy, I'm not thrilled with the name on this one, but I call it clone and slash. The idea here is we've got a system that's maybe excessively coupled. We want to start deploying it in smaller pieces, but we don't really know how at this point. And it's just too big. So anytime we've got a problem that's too big, we want to find a way to divide and conquer. So the plan here is that we split up into teams and we hand them each their own complete copy of the code base. So you literally clone the code base, you fork it into multiple different repos that all have 100% of the same code, and then you tell each team, do whatever you need to do. Your stuff has to keep working. You can change the other code however you like. So if you're changing your part and you're breaking other far distant pieces of code, that's okay because nobody's calling that. This moment can be a milestone in your company's history. Everyone on every team will remember when they got their own copy of the code base and they could mutate the hell out of it however they wanted. I saw one team that had a deletion party. They gathered around a big screen on a conference room. They were deleting code, drinking beer, deleting more code. Someone would go, oh man, I hate that class. Kill that one next. And they talked about this for years afterwards. Now, we are talking about the code. And of course, when we talk microservices, one of the core tenets is every microservice has its own database and its own persistence. This will not give you that. In this approach, you will be sharing your database for quite some time. So again, you regard this one as a transitional stage where you're beginning to introduce the decoupling, you're beginning to break it down in a recursive process that goes from monolith to big blocks of stone, to smaller blocks of stone, to gravel, then sand. And I think that's one of the overriding success patterns I really want to call your attention to. This is not a transformation that ends at a destination. This is a new way of working. You have to keep the pressure on to keep changing. I've talked to some people who say, yeah, we went to microservices, we've got about 12 services, and I ask, how long have you had those? Well, since we went to microservices. How many new ones have you created lately? Well, you haven't created any new ones. How many have you deleted or destroyed? None. That is not really taking advantage of why we moved to microservices. That's bringing in all the operational complexity, but without gaining the agility or the maneuverability that you really want. So we want to keep the pressure on to keep redesigning things. Now, this can feel a little awkward, especially if you've really put your heart and soul into breaking up this monolith, and here's some service with a beautiful abstraction that you created, and now 6 months later, someone's proposing to destroy it. You know, shut it down in production, we don't need the code anymore. It feels wrong, feels bad. But this is, in fact, part of why we want to do microservices, so we can get that evolutionary character to it, where we are introducing new things and we're removing the ones that we either don't need or the ones that just don't work. Not every design you come up with is going to be a good one. If you design 12 microservices and you live with those for years, you'd better be very, very right in your design of those services. That's hard. Much easier to continue adapting where the consequence of your decisions is not so great. Another success strategy that I particularly like is doing services by life cycle. So this is a counterpoint to the entity services. And the idea here is that many of our business processes have this character where at a certain stage, a bunch of fields are mutable and everything else is undefined. And you move to the next stage and you've got a bunch of fields that are mutable. The old ones are now read-only because you've passed some gate in a process where they're fixed, and then these are undefined. And you keep stepping through, and in some of these processes, going back to an earlier stage really means going back and beginning again from that stage, where I'm now moving forward through approvals and so on. In these kind of processes, I like to use this services by life cycle and say each stage represents its own service, and I'm passing documents between them. Another failed strategy is putting domain objects directly on the wire. We've got frameworks that like us to do annotations, at entity maps it to a database, at JSON maps it onto the wire. If you take a domain class and you map it in both directions, it can't change for anything. I think that these domain objects put directly on the wire make it exceedingly hard to evolve your APIs. What I would much rather see you do is treat the mapping, the auto-wiring, as a message format and keep the meaning in the domain layer proper. If you do that, then keeping multiple versions of these annotated classes for the messages is no problem. They can continue to coexist. On the other hand, if you put them in your domain, and now you have a V1 and a V2 class in your domain, they have to share some supertype so that other classes can use them. You have to decide how the logic is going to work inside of those, and it's a lot of weight to carry around. I'd much rather keep that out at the periphery. So I like to treat request data as data, not objects. So I typically bring in my request objects as hash maps, lists, and vectors. The counterpoint to domain objects on the wire is the hexagonal architecture or the ports and adapters pattern. So this says that the domain is independent of any of your technology concerns. The domain doesn't import any types from your persistence. It doesn't import any types from your UI framework. You could run it alone in its own process for testing and so on. The domain becomes smaller, and you can now treat multiple outbounds as all being targets of the domain. That looks a little bit like this. The idea is that things on the left generally initiate communication, things on the right generally receive communication, and the adapters for each one are like a little stack of layers. So on the outside of the user's adapter, where I've got a GUI, my types are expressing things like HTTP request, HTTP response, session, cookie, and so on. That is where I put my annotated classes that map to payload. Once I get into the domain, I'm talking more in terms of a command about the domain, a unit of work, and then mapping back out to the database goes from domain concepts out to rows, tables, columns, and so on. So this allows us to persist or to use multiple versions of our message format classes and continue evolving our APIs and allow those versioning while keeping the domain independent. There's a lot to like here. My overriding message with almost all of these is that the approaches that try to create a grand narrative tend not to work. The ones that do work are the ones where you're thinking about the long term, but you're working in the context that you have. You're working in the short term. Now, you can't just work in the short term and think short term. That also leads you down a bad path. But if you keep your eye on the horizon and you take the next step, and then you take the next step, then you can get where you're going. So in The Martian, Andy Weir talks about how you need to do the math and work the problem. And I think that's true. We need to solve the problem that's in front of us. Work the problem we have now. The next one might not be the one you expect. You may take a detour from working on your domain services or your domain functionality to build a service to help you manage the other services. That happens. That's okay. You may arrive at a destination that's not the one you would have foreseen from 2 years ago. That's also okay. Your system can show its history, can show its scars, can show its character, and that's okay. So solve the problem in front of you. The next problem probably won't be the one that you expect. And that's my experience with grinding the monolith. Thank you.